Hey everyone, welcome back. In this video, we will walk through setting up PostgREST, a powerful tool that instantly turns your PostgreSQL database into a fully functional RESTful API. You can use it to build internal tools, public-facing APIs, or anything in between, all without writing backend code. We will cover installing PostgREST and configuring it to connect with your database. By the end, you will have a working REST API backed entirely by PostgreSQL. Let's start by looking at the Docker Compose setup. I have defined two services, one for PostgreSQL and one for PostgREST. PostgreSQL is set up with a database called PostgREST tutorial, along with the user and password that PostgREST will use to connect. We are also mounting an initdb directory with scripts that run when the database container starts. The PostgREST service connects to the database using the db URI environment variable. It also specifies db unknown role, which tells PostgREST which role to use for anonymous access, in this case, web unknown. The depends on setting ensures the database starts before PostgREST, and both services are set to restart automatically if needed. Now inside the initdb folder, there is a script called webenonrole.sh. This script creates the webenonrole role and gives it read-only access to the public schema. That includes usage on the schema and select access on all tables, enough for Postgres to serve data without authentication. With everything in place, we can now run the services. In your terminal, just run Docker Compose app. This will start both the PostgreSQL and PostgREST containers using the configuration we looked at earlier. Once the containers are up and running, open Postman or any HTTP client and send a GET request to localhost 3000. If everything is set up correctly, you should get an OK response. This confirms that PostgREST is up and able to connect to the database using the web unknown role. At this point, the API is live, and PostgREST is ready to serve data. We just need to define a table to test it. To test the API properly, we need some data in the database. I have prepared a SQL file called lego.sql that contains a few sample tables and rows. To load it into the running Postgres container, we use the following command. This copies the file into the container so it's accessible from inside Postgres. Next, we run the SQL file using PSQL inside the container. This loads all the schema and data from the file into our Postgres tutorial database. Once that's done, the tables are ready to be exposed to PostgREST. To make it easier to explore and test our API, we can add Swagger UI to our setup. Swagger UI provides an interactive interface to browse and call your API endpoints. We will modify the Docker Compose file by adding a new service called Swagger UI. This service is the official Swagger UI image and is set to run on port 8080. Here's what the edition looks like. Notice that the API URL environment variable points to our PostgREST API running on port 3000. Once this is added, we will restart all the services with Docker Compose down and Docker Compose up. Restarting is also necessary because PostgREST does not support live schema changes. This means it won't detect new tables or changes if they happen after it starts, so every time we add or modify database schemas, we will need to restart PostgREST for those changes to be recognized. After the restart, you can open your browser and go to Swagger UI, where you can explore the API endpoints exposed by PostgREST interactively. You will see a list of available endpoints generated from our database schema. Let's try a simple GET request on the Lego part categories endpoint. This will fetch the list of categories from the database. Click on the GET method, then hit try it out and execute. You should see OK response along with a list of categories returned from the database. Next, let's test what happens when we try to add a new category using a POST request to the same endpoint. We'll make the POST request without supplying any data, since the details aren't important for this demo. Hit try it out, leave the request body empty, and click execute. You will see a 401 unauthorized response. This happens because the web anon role we created only has read access, no permissions to insert data. This shows how Postgres enforces a role-based access control directly from the database roles. That wraps up the basic PostgREST setup. We now have a live API backed by PostgreSQL with Swagger UI to explore it and anonymous access configured through database roles. While we only touched on the basics of role-based access control, this setup lays the groundwork for more advanced features, like role-level permissions and authenticated access. In the next video, we'll take this further by adding authentication and showing how to secure write operations using PostgREST role system. Thanks for watching and see you in the next one.